So for instance, if you're doing a problem like this that says, let's divide the polynomial 4t squared minus 4 times t plus the number 1, and we're going to divide that by 2t plus 1. All right, so the first thing is, the problems are usually given to you in this format, so the first thing you have to do is write them under the division symbol and so on, like we know how to do. And so you're dividing by this, so this goes on the outside. So I'll put a little arrow here saying we're kind of converting the problem into the following form. 2t plus 1, this goes on the outside. Then you need to draw a division kind of symbol here, and then this term goes on the inside because this is what we're dividing, essentially. So we have 4t squared. Give yourself some room so you don't crowd things up too much. 4t plus 1. Now, I'll kind of go over it several times, but just to kind of bring it home here. You see on the outside, we have a t term, t to the first power, and then no t at all. So we have a t to the first, t to the 0 is kind of invisible there. So we don't have any missing terms here. Here we have a t squared, then a t term, then a constant term. Again, we don't have any t terms missing there. And so in a future problem, if you're missing, like if we were missing the 4t, if this problem were 4t squared plus 1, then underneath the house, we would have to put a 0t. You have to have a placeholder for every power of the variable you're dividing. All right, we talked about that a little bit in the last lesson. All right, so what we're going to do now is focus first only on the first term out here and the first term in here. 2t times something has to give me this. Now we all know that 2 times 2 is 4, so 2 is the number that goes here. And then t times something will give me t squared. T times t gives me t squared. So this is how we're going to do every problem. You look at the first term on the outside and the first term on the inside. You're ignoring the one, you're ignoring everything after, and this is kind of analogous in long division of numbers, how you kind of focus on the first digit on the inside as you start the process. Now, once we have this written here, we start to multiply down by this term. 2t times 2t is 4t squared. It should always match what you have above. But don't forget, you have a 2t plus times a positive 1, so you have a positive 2t. Now, when you do the next step, you're always subtracting. Be careful. Do not just put a minus sign here, because this, of course, looks like a minus sign, but you're going to forget eventually, if you put it here like this, that really this is a minus 2t. So what I always tell people to do is put a little circle around it. That kind of forces me to remind myself that it's 4t squared minus 4t squared. That gives me 0. And then negative 4t minus this 2t. It has to be a minus, so that's going to give me negative 6t. One of the biggest problems in polynomial long division is when you're doing the subtraction, you're not careful, and you have to make sure that it's the first thing minus the second thing. So it's a negative 6t. You're not adding these things together. Once you've done the subtraction, you drag the next digit down, which is a positive 1. Right? Now that we've done the subtraction and we drop the next digit down, then we focus again to this term and then the first term here. So again, you're only looking at first terms. 2 times something gives me negative 6. That has to be a 2 times a negative 3 to give me the negative 6. And then t times something to give me a t. So really, it's going to be t times, well, I don't need a t here. Think of it this way. 2t times the negative 3 is going to give me the negative 6t that I have there. So I don't need to put a t here. When I do this multiplication, I'm getting the t that I need, right? So it's this times something gives me this. So when I do the multiplication this way, of course, I'm going to get the negative 6t. And then the negative 3 times the positive 1 is going to give me negative 3. So I have to subtract like this. And then what you're going to do is you're going to do a subtraction. Negative 6t minus negative 6t is going to give you 0. And then you have to subtract the next term. You have 1 minus a minus 3. So it's 1 plus 3, which is 4. This is why you have to be really careful with this sign, because the negative sign kind of goes in and makes it, you can think of it two ways. You can think of this negative sign going in, making this positive, or you can just think of it as subtraction. 1 minus a negative 3. You know that minus a negative means positive, so it's 1 plus 3, which is 4. Now that we've done that subtraction, there are no more digits to bring down, no more terms to bring down. The degree of what we have here is lower than the degree of this thing. What I'm saying here is this term here is a first degree term because it's t to the first power. We've done the division process. You basically stop the process when you get a 0 remainder, or if the remainder that you get is of lower degree than what you're dividing by. This is a degree 0 because there's no t term at all, or t to the 0 is another way to think about it, and this is t to the first. So we're going to stop there. This is effectively our remainder. The answer is 2t minus 3, remainder of 4. But we all know that we're not going to write remainder of 4. We're going to write it like this. We're going to say the answer is what we get at the top, the 2t minus 3. That's the whole part, how many whole times it goes in. The remainder represents the fractional part, so we have to put a plus. This is the fractional part, and it's a fraction of what? A fraction of what we have divided by, 2t plus 1. So we've talked about this in the last lesson, that this represents the whole number of times this thing can be divided, and this represents how many fractions of a time it can go in, after the whole number of times there. So 2t minus 3 plus 4 over 2t plus 1. Now, I'm kind of been baby stepping a little bit through the process. Now that we kind of are getting our bearings on how to do this, we're going to speed up just a little bit, but I'm not going to skip any steps going forward. We're not skipping anything. I'm just simply saying that we are going to go a little bit faster. So for our next problem, we have x cubed minus x squared minus 10x plus 10, and we're going to divide that by x minus 3. The very first thing we want to check is, do we have descending powers of x? We have x cubed, x squared, x to the first, x to the 0, which is a constant term. So we don't have any missing terms. Here's x to the first, x to the 0. So we don't have any missing terms. So we don't have to insert anything. So we're dividing on the outside by x minus 3. And on the inside, I'm going to go and draw a long house here. We have x cubed minus x squared minus 10x plus 10. And then we only look at the first term. X times something gives me x cubed. This has to be x squared, because x times x squared will give me this. Now I go do the multiplication, and I'm going to get x cubed here, and then x squared times the negative 3 will give me negative 3x squared. I have to subtract them, so I'm going to put a circle around it to remind myself that both of these terms are subtracted. The x cubed subtract to give me 0, but here you have to be careful. Negative x squared minus a negative 3x squared basically means it turns us into a plus sign. So minus and negative makes plus, so what you end up having is negative 1x squared plus 3x squared, and so the answer is 2x squared. So essentially it's negative 1 plus 3. That's what you get there, negative 1 plus 3, which is going to give you a positive 2, and of course the x squareds come along for the ride. Now once we've done the subtraction, we drag the next term down, which is a negative 10x. And you repeat the process, only looking at this one and this one. So you have x times, or you have a 1 in front here. So 1 times something is going to give me the 2. It's got to be a 2 here. And then the x times something is going to give me the x squared. I have to have an x there. It's because x times x is x squared. Now I do the multiplication. This times this gives me the 2x squared. And then 2x times the negative 3. 2 times negative 3 is negative 6. And then you have the x times 1 there. And we're going to, again, subtract both terms. The first terms always subtract to give me 0. Now you have to, again, be careful. Negative 10, forget about the x for a minute. You know you're going to have an x in the answer. Negative 10 minus a negative 6. So when you have minus a negative 6, it means it's a plus 6. So you have a negative 10 plus 6, which is going to give you negative 4. And of course, you have x coming down there. Again, negative 10 minus a negative 6, so negative 10 plus 6. Okay, once I've subtracted that, I drag the next digit down, which is a positive 10. And again, I only look at the first terms. You have a 1 times something to give me negative 4. That means I have to have a negative 4 here. And then the x times something to give me the x is just a 1 there. So really, I don't have anything required to give me an x. Now I do my multiplication. Negative 4 times the x gives me negative 4x. Negative 4 times the negative 3 gives me positive 12. And I subtract, again, with a circle to remind myself I'm doing both terms. These subtract to give me 0. 10 minus 12, so 10 minus 12 is negative 2. So the remainder that I got is negative 2. So the answer is, this is the whole number of times, whole amount of times it can go in. You have a remainder of 2 left over. You know that you can stop because the remainder that you got is a lower degree than what you are dividing by. This is degree 1, this is degree 0, because it's like x to the 0th power. So the answer that you're going to write down is the whole number of times x squared plus 2x minus 4. But then you're going to have to add the fractional part, which happens to be a negative 2. And it's a fraction. Negative 2 as a fraction of what you're dividing by is x minus 3. Now, yes, I know I have a negative 2 there. I could float the negative sign down here. You can do those things if you'd like, but I really just like writing the whole number plus some remainder. If what the remainder is happens to be negative, I just kind of leave it up there. If you want to float the negative down, you can. So that's the final answer. Let me just double check myself. X squared plus 2x minus 4 plus negative 2 over x minus 3. The remainder will always be divided by the divisor, what you're dividing by, just as we discussed in the last lesson when we talked about dividing numbers, because the same thing is happening. When you divide something in a calculator and you get 9.5, it's because when you do this process, the remainder you get is a fraction of what you're dividing by. That's where the decimal comes from in the calculator when you're dividing numbers. We talked about that in the last lesson. Now here is one that I want to make sure and do for you. I really want you to pay attention to this because it's a great way to miss a problem for no good reason. So if you have 2x cubed minus 29 times x plus 13, and you're dividing that by x plus 4. Now in the bottom, we always check. We have an x to the first power, and we have a constant term, which is x to the 0, so we're not missing anything here. But in the top, we have x cubed minus x. So we have x cubed and we have an x term, but we don't have an x squared term. So probably one of the biggest mistakes that you can make is the following. A lot of students will write it like this. They'll say, we're dividing by x plus 4, and they'll build their little house there, and they'll write it down just like it's written, 2x cubed. I'm going to skip a little space here. They'll say like 29x plus 13. You can kind of pretend this is all written together. They'll just kind of write the polynomial out exactly as it's written there. You will not get the right answer doing this process without putting a 0x squared here. So I've been telling you from the beginning, everything you write down has to be descending powers of x. X cubed, x squared, x to the first, x to the 0. Here is x to the first, x to the 0. You have to have the descending values. And the analogy that I think I mentioned before is if you're dividing 503 divided by 6 or something like this, you see how we have to put a 0 as a placeholder here. It's just kind of like the 0 tells you, 0 has a value of 0, but it doesn't really fully mean that it's a 0. What it's telling you is there's a place value. This is the ones place and the tens place. The 0 exists really to bump the 5 over to the hundredths place. So if you actually forget to put that 0 there, I know it sounds silly, but you would be writing 53 divided by 6. We all know that 53 divided by 6 is not the same thing as 503 divided by 6, but it's the same thing. If you forget to put the 0 in there, if you're like from an alien from another planet, you might think, why are you putting a 0 there? It means nothing. But it doesn't mean nothing. What it's telling you is you have 3 in the ones place, 0 in the tens place, and 5 in the hundredths place. If you don't put that here, the 5 no longer has the hundredths place meaning. So that's why this is wrong, right? If you don't put a 0 here, then the polynomial that you have, the placeholder, is all wrong, and it's not going to go through the algorithm properly. And I've tried to kind of explain why, but I'm trying to show you by analogy. That's why you have to put these zeros in there. It would be like doing something crazy like this. All right, so now what we're going to do is we're going to say x times what is 2x cubed. I'm going to have a 2 here, and I'm going to have to x squared here. Why? Because this times this gives me 2x cubed. 2 times 1, and then x squared times x. And then I have to multiply times the 4, so I'm going to get an 8x squared. And then I have to put a minus sign there. I'm circling it, so I remind myself, subtract these, I get 0. And then 0 minus 8, see, if you don't put that minus sign there, you might add these together. 0 minus 8 is negative 8x squared. And that's why I don't want you to just put a 0 here. I want you to write 0x squared. That helps you remember when you subtract them, the answer is negative 8x squared, right? So I don't want you to just put zeros here. I want you to put 0 and then the variable to whatever power that is missing. Okay, now that we've done the subtraction, we can drag down the next number, or the next term, negative 29x. And then I say x times what is negative 8x squared. So I need a negative 8x. Why? Because negative 8 times the 1 gives me negative 8. X times the x gives me an x squared. So when I multiply it, I get negative 8x squared. And then when I multiply this, negative 8 times positive 4 is negative 32x. And I'm going to subtract both of those. Subtract these negative 8x squared, so I'm going to get 0. Now here's where you have to be careful again. You have a negative 29x, and you're subtracting a negative 32x. So it's really a negative 29 minus a negative, which means plus 32. So negative 29, if it helps you, go over here and say negative 29 plus 32, because the negative makes it plus. Whoops, plus 32. And you can see by writing it like this that the answer you're going to get is 3. And not just 3, but 3x, because that's what we're subtracting. So I've done that subtraction. I'm dragging the next guy down, and I'm going to have a 13. Again, I look at the first term, and I know I have x times something gives me 3x. I have to have a 3. Why? Because 3 times x is 3x. Multiply the next one. 3 times 4 is 12. minus, I have to have a circle, subtract the first terms to give me a 0. 13 minus 12 gives me a 1. The remainder I get is now a lower degree than what I had here, and so now I know I can stop. And so the answer I'm going to get is what's on top here. It's going to be 2x squared minus 8x plus 3 plus the remainder, but expressed as a fraction, is 1 over what I'm dividing by, x plus 4. So let me double check myself. I have 2x squared minus 8x plus 3 plus fraction 1 over x plus 4. So this is the correct answer. Again, if you miss the fractional part, it's wrong. If you miss any of the terms here, it's wrong. And I guarantee you, if you don't put the 0 in here and go through this process, it's going to be completely wrong. It would be kind of like dividing 53 instead of 503 and expecting to get the right answer. All right, great. Now we have one more. You can see that the progression of complexity in all these problems, it does make the process longer, but it doesn't make it harder. It just becomes a little more tedious. When you have a square divided by a first power, they're about this long. When you have a third power divided by a first power, they're a little bit longer, but the process is exactly the same. Here we had, again, a third power divided by a first power. It was this long. And for our last one, we are again going to do a third power, and then when we get on into the next lesson, we'll actually do some fourth power divisions, but the process is the same for all of them. Here we have 6t cubed plus t squared plus 7t plus 10. And now we're dividing by 3t plus 2. So 6t cubed plus t squared plus 7t plus 10, 3t plus 2. Now in all the previous problems, let me just double check myself before I lie to you. In all the previous problems except for this one, in all of these, what we're dividing by here is just a x plus something with a 1 in front, and x minus something with like a 1 in front. And the first one we did was similar to this, but here we have a t plus 2, but it's 3t plus 2. So the process is the same. Nothing really changes. We do have to make sure it's a power of 3, power of 2, power of 1, power of 0. Okay, we're not missing anything. Power of 1, power of 0. Okay, we're not missing anything. So we're dividing by this on the outside, so it would be 3t plus 2. And we'll draw a very long little house here, and we have to write this down. 6t cubed. Leave yourself some room. That's another thing I always see students do, is they write things too close together, and then basically you're scribbling and you're erasing and you never have any room. You have to give yourself room to breathe. All right, 3 times something is 6. 3 times 2 is 6. T times something is t cubed. You have to have a t squared. Multiply here, you're going to get 6t cubed. Multiply here, 2 times 2 is 4 t squared. Subtract with a little circle there. 6's in the t cubed, subtract away. Now you have a 1t squared minus a 4t squared. So it's 1 minus 4, which is negative 3t squared. So we've done the subtraction. Now we draw our little arrow. And I do want you to draw that little arrow because it helps at a glance when you go back to realize that you brought all the digits down. If you don't draw these arrows, sometimes you get confused as to what you've done. All right, so now we have to say 3t times something is negative 3t squared. So you have to have a negative sign, and you have to have a t. And we're going to multiply and verify. Negative t times the positive 3t is negative 3t squared. And then the negative t times 2 is negative 2t. We put a minus sign, subtract, draw our line. This gets subtracted to 0. Now you have, forget about the t's, 7 minus a minus 2. So 7 plus 2, so you have a positive 9t. Let me just double check myself and make sure I didn't make a mistake. Yep. And then we have a 10 that we now drag down once we do the subtraction. Again, we look at the first term. We have 3 times 3 is 9, so we're going to write a 3 here. The t's are the same power, so we don't have to multiply anything to get that. So essentially, we multiply 3 times 3t does give us 9t. That's all we're trying to accomplish. And then the 3 times the 2 is 6. We subtract, put a circle, subtract the 9t's, they go away. 10 minus 6 gives us 4, and now we have a degree here smaller than what we had here because we don't have any t's here and we have a t here. Notice that if we tried to stop at this step after this subtraction, we have a 9t. The degree of this term is not lower than this, so we can't stop. And if you try to stop, where else would we try to stop? Maybe here after this subtraction, then of course you have a t squared, which is not a lower. So basically you can only stop the process when you get a remainder of 0 or when the remainder of what you get is a lower degree than what's on the outside, the divisor. All right, and so now to write the answer, we have what's on top. So we have 2t squared minus t plus 3. That's the whole part. The fractional part is 4 remainder, but as a fraction of what we have here, 3t plus 2. And that's the final answer. Let me double check. 2t squared minus t plus 3 plus fraction 4, 3t plus 2. That's correct. So the concept of polynomial division, it's one of the hardest things that students really struggle with, I think, in algebra. I think most of the reason why people struggle with it is simply because it looks so intimidating. There's t's running around everywhere, exponents everywhere, but by reviewing the concept of basic division of numbers and doing easier problems and working our way up here, we're getting our practice. So we have one more lesson where we're going to increase the degree. We'll do some 4th degree polynomials there. But the process will not change between any of them. So there's no special rules. There's no nothing crazy that you have to learn different. You're going to do the same thing. We're just going to have longer problems. So follow me on to the next lesson. Do all of these problems yourself. Make sure you can conquer them, and then follow me on to the next lesson where we will wrap up the concept of dividing polynomials. Learn anything at mathandscience.com.